Hi everyone, welcome to my channel and thanks for tuning in. I'm here to solve another Leetcode question with you. The question that I picked up for today is question 328, odd, even, linked list. Given the head of a single linked list, group all the nodes with odd indices together, followed by the node with even indices, and return the reordered list. First node is considered odd, the second node is even, and so on and so forth. So if you're giving this linked list with these values 1, 2, 3, 4, 5, the result will be 1, 3, 5, 2, 4. It's so important to keep the order as it is. So it says the relative order inside both the even and odd groups should remain as it was in the output. That's an important point. You must solve the problem in O of 1 extra space and complexity and O of n time complexity. So basically it means that you cannot use any sort of array or mapping or any kind of hash set to store anything. So you need to do this mostly in place. And since the time complexity is linear, then we got to do it in like one or two or like a constant number of rounds. So this is the first example. The second example is kind of bigger, but again, it shows that the odd numbers have appeared first, ones that are white, and the purple ones have appeared later. The constraint is not that big of a deal. All right, so let's get to this question. Right off the bat, we have a linked list similar to this. Okay, and we do want to turn this into this linked list: 1, 3, 5, 2, and 4. Something that comes to my mind intuitively right away is, for example, we can go all the way. We can have this node as head, and then we traverse the linked list once. We found the end node. Now we have 2 pointers, and then we can go over every other node and move them here. So it would be something like this. Then remove this, and then connect this one to next one, and get rid of this. I'm gonna do this a couple times. So next round, 2 would be pointing to 4, and 3 will be pointing to 5, and 4 would be pointing to null. This is one approach, but the other approach that would actually make it even easier than this is to just traverse the linked list once. And as we are traversing, for every other node, we do this thing. We store them separately on a list of even nodes. And we store them separately here. We add 4 to this list, and we remove it from here, and then eventually connect this one to this one. So this would be, in practice, it would be easier. It's kind of easy to understand what needs to be done, but it's the implementation that can become a bit tricky as we are trying to get into that. So knowing all of this, we need to go through this linked list. We can say that if we only have one element or no element, if head is null, and it's so easy to do that in Kotlin, I love Kotlin, just return null. Otherwise, we're going to return head. We're not going to touch head. And what we need to do is we need to have at least 2 nodes. So one would be the even node. So I'm going to name it even. And we can right away set it to be the next element of the head. And then we can also have another element here, and we can set that to be head. And that's for us to get through it. And as we are going through this, make sure head is not null. We need to do a couple of things. Let me use a different color. So this is our H. This is our even. So first things first, head next should be even next. So we got to get rid of this, and we got to point this next element of head to be the even's next element. And then we got to move head, edge to next. Perfect. And even next should be head next. So we're going to get rid of this. And heads next should be... No, that's pretty fine. Because next round we're going to say that... yeah. So I'm going to say that even should be even that next. So this would be even. And then we will be in the same place as we started. Now, the difference here should be that even should not be null. And also we have to check even next because we want to make sure this item is not null either. So basically this one. No, that's not needed. I don't think that's needed. And in here at the very end, we got to connect these two lists together. We got to connect the next element, the last element of the head to be linked to the beginning of the even list. So for that, we're going to create another node. We're going to call it even head. And that would be head next. And even could be just starting with even head. And here, you're going to say head next, be even head. And yeah. Okay, now let's run it. I'm sure there are probably different errors that we need to cover here. I'm going to cover them. So we need to be sure that edge is not null. So we know that edge is not null. Okay, we got a null pointer exception here. So I'm going to make sure that edge is not null in here and in here. Oh, this should also be head in case that we only have one element in the list, so we don't want to just necessarily just return null, which is not correct. And as we're doing this, so we reach here again, even is not null, and what's going to happen in another round? Let me figure this out, and I'm sure then we can also figure out the compiler that we're seeing here. So edge next should be even next. So that would be the next element of h. And then the even's next element should be h next. Oh, h would be h next, so h will come here. And at this point, even's next element would be here, and which is null. Then we're going to set even to be equal to even next. So even will be null at that point. And then edge next would be even head. I think this is good. Let me run it one more time. So that's all pretty good. We are getting a good answer for this case and this case. So we have odd numbers in those cases, but all right, it looks like if we have an even number, then we're going to run into a problem. So let's imagine we have a 6 in here that's connected. So even next would be edge next. So we got that covered. And then even would be equal to even next. So this would be even. Perfect. And this would run again. And again, even is not null. Now in here, edge next would be even next. So, oh, okay. So what's going to happen is we're going to point the edge next to be here, which is null. And then we're going to make it null. And then next for a null would not even make any sense. So we have to check for even and its next node in here so that they both would not be null. So to do that, I'm going to add this small magic code in here. Let's try to run this again. All right, we got 3 accepted answers for 3 different test cases. Let's submit it. And awesome, we got an accepted solution, which beats 44.96, almost 45% of the other submissions. So the time complexity here is O of n, and the space complexity is O of 1, simply because we're not using any extra space, and we only go through all the elements of the linked list once. Thanks for being with me. I wish you enjoyed this one. If you enjoy this kind of content, please don't forget to like and subscribe. I'll see you guys in the next video.